Today we're doing 5.4. We're not going to do two things, so he'll have the second period to work on things. There'll be another example that I still need to teach from 5.4. We'll do that on Friday. Okay, who's done the bisection method before? Who's done that? Okay. When you think about bisection, if you were to pretend that you knew it, using the word bisection, what would you say? Two sections. Okay. Anyone else? Hassan? You split it up. Okay. So we are simply splitting things up. I'm going to do a magnified version of that graph over here. And we have an estimation of roots. We're splitting things up and we're estimating of roots. What are roots again? Solutions. They're solutions. What are roots and solutions? What are they? They're x-intercepts. It's all mainly about x-intercepts. We've got a graph here, polynomial x cubed minus 2x squared plus x minus 3. They're giving you a clue here in the first question. They're saying that there's a root that lies between 2 and 3. So we're starting from 2 all the way to 3. But on here, if we were graphed it, got 1, 2, 3. What we're trying to say is we've got a graph that we don't know what it looks like, but they're saying this graph here, this cubic, is going to come and snake its way in between here. But we don't know where that is. They're saying, let's say it is between 2 and 3 though. So it says they show that the equation x cubed minus 2x squared plus x minus 3 has a root that lies between x equals 2 and 3. If they're asking you to show it, we're simply going to punch in what's happening at 2 and what's happening at 3 with our equation. We're simply going to substitute that in. So 2 cubed minus 2 times 2 squared plus 2 minus 3. 8, take away 8, plus 2 minus 3 equals -1. If we look on the other side on 3, you must substitute it in like so. 27 minus 2 times 9 plus 3, take away 3 is gone. 27, take away 18 is a 9. I've got a 9 here and a -1. How does that show that there's a root in between 2 and 3? Can someone explain? What's the concept here? Got two answers. It's falling between those, sort of. Good starting point. Something else about these numbers. They're both 10. They're both not quite 10. Good try. 0 is between them. We're getting closer. So Maya said there's a 0. We're at -1 and 9. These are y values, remember? Y is -1, which is back here. And then 9's up here. So we know that at 2, -1 it's here, and at 3 it's back here. Our coordinates. I've just put these coordinates, one in here and one in here. But what I'm trying to get at with Maya's contribution there, from -1 passes through 0 to 9. Once you've established a negative value on the y, the other one must be a positive if it's going to go through a root. If this is positive and your other boundaries are negative, that's also another good thing because it's passing through 0. between positive values and negative values. Okay. When I ask you to show that, you are showing that there's a change in the sign. Because a change in the sign means passes through zero, which means there is a root there. That's all you need to do for that question. Okay. And if you were to see the sentence, you can read that to yourself. There's two ways of saying that. P2 is less than zero, it's a negative. P3 is greater than zero, positive. There is a value of x that lies between 2 and 3, where it's a zero. This second sentence says exactly the same thing. All right. So it says there, state the first estimate of the root. We know that we've gone from 2 to 3, or 2 to 3 in here. We're going to estimate it. The way we estimate is we do a bisection. Hudson said splitting up. And Tim, what did you say? You said two. What did you say, Tim, about bisection? Two sections. Okay. So we're going to create two sections between 2 and 3. The most appropriate mathematical way to cut this in two is where? Halfway. It's halfway point. We know between 2 and 3 is 2.5. Or you can just simply say, when it gets a bit trickier, you're just going to add them and then divide. 5 on 2, we know it's 2.5. We're guessing, using bisection, that the root may be halfway between these two. Okay, pretty logical sort of guess. Okay, so x equals 2 is our first estimate. I mean, x equals 2.5. It's down here. That's where we think the root is. It may not be. If you'd like to cheat right now, you can go to your calculator, do a root on the CAS, you'll get it. But these questions, you're not going to have your calculator at hand unless you want to go through the whole long division process. But the key word to this topic is estimating. We are estimating right now. Okay. So our first estimate is a 2.5. Just need more space. My eraser. Okay, what did we say at 2? What's the y value of it? -1. And at 3? 9. Okay, now we're going to see when x equals 2.5, p 2.5, what happens? So 2.5 cubed minus 2 times 2.5 squared plus 2.5 minus 3. Okay. It might be better if you don't have a calculator to be doing it in fractions. Oops. Okay, so this is good practice for us because exam 1 next year, you've got a lot of fraction stuff and you've got to be able to do that and be confident in your own ability without a CAS in your hand. 5 on 2 cubed, what's that going to be as a fraction? Over 8. Okay. Over here, we've got how many 2's do we have on the bottom? And how many 2's do we have on top? And what does that mean? So I've got a 2 on top. I've got 2 squared, which is 2 times 2. And I'm left with a on top, 5 squared. So we can cancel these out. You've got your 5 on 2 minus 3. You got to keep going. 1, 2, 5 on 8 minus 25 plus 5 on 2 minus 3. Okay. Thank you. Thank you very much. Okay. Let's pick up these. There's many ways you can do it. With the working out, we can combine them. 8 on with a denominator of 8, denominator of 2, or so let's 25 on 2, 5 on 2 minus 3. What's these guys going to change into? Don't forget the negative. Minus 20 on 2 minus 3. Okay. 125 on 8 minus 10 minus 3. Try and do as much working out as you can to avoid making any mistakes, like I just did here. Minus 13. Okay, anyone got an answer? This one. Okay, 125 on 8. Remember that's on 1. Okay. Crunch those numbers in your head. You can use a pen and paper if you want. I've got my solution here. What is 13 on 1 with a denominator of a in 1? Tim? 10. What's the number over here? 104. Good. Okay. 125. They're now both over 8. Difference between 125 and 4 is 21. Okay. So 21 on 8. Can someone punch in 21 on 8 on your calculator right now? Just need an idea of this as a decimal. What's 25 on 8, Zach?
21 on page 2.62.
2.62. So 2.5, it's 2.625. Does that mean 2.5 is a root? No. What should I have in the bracket for it to be a root? 0. Okay, next question. Where's this root? Is it on the left or the right? Right. Okay. Some say left, some say right. It is on the left. Why? That's right, Emily. So we still have a negative with a positive. If I go over here, still all these are positives. We don't want that. We want to keep coming closer between a negative number and a positive number. Therefore, what is my next bisection guess? What are we going to look at? 2.25. Take the tip. We're now going to pick on 2.25, which is in the middle. Yeah. And then you keep going. So this is our third estimate. X equals 2.25 is now our third guess. And for this question, you can go on forever. Well, not forever, until you hit a 0. Okay. Which is the next question here. Almost done. D, continue the iteration. It just means repeat the process using a calculator until the error in using this estimate as the root of the equation is less than 0.05. Okay, so I'm going to have to stop the recording because I've got to show CAS on here. Can everyone now get your CAS, please?